Okay, I guess it's time to start with the second session of the day. So first, just a quick note, as Christian already said, all the attendees, all the people joining are all muted because otherwise it would be impossible. If you have any question, please use the Q&A window for question, or just feel free to chat in the chat box. Christian will be around and answer things while the session goes, or we can just answer question at the end of the session. So now it's about to talk about data lineage made easy with graph databases. The idea is really to show you how you can use a graph database to really help you in data lineage and all these kind of activities. So first of all, what is data lineage? Because it's something that it's often said, but what it is for real, and why actually do you want it? Well, it's extremely simple. Why do you need it? Because we all love black boxes. I hate black boxes. And there is nothing worse than just having a company with a bunch of black boxes transforming whatever kind of information into dashboards. For example, if you are a shop, you probably are taking at the moment all your customers' information, doing some cooking, and at the end you have some dashboards without exactly knowing what's going on. What exactly are you doing? What are the business rules? What are the calculations? What are the measures, the formula that you're using? That's where data lineage can help you, just to clarify all these things. And why data lineage become important? You probably remember 2 years ago, more or less, there was this thing called GDPR. If you are not in Europe, it's mainly a European thing, but it really impacted everybody because it doesn't apply to European companies. It applies to any European data. So every information about a European person, you fall into the GDPR thing. And there was this panic going around, oh, 2018, GDPR, it's gonna be the end. We're over. Well, nowadays, it's already 2 years after. We're all still alive, so GDPR wasn't that bad in the end. But let's first have a quick look. What is GDPR? It's simply giving back the permission on personal data from the, let's say, the companies or the owner of websites to the person, to the human being behind this information. So any kind of information that can be linked directly or indirectly to a person is now owned by that person. So companies are not allowed to process your data without explicitly asking you, can you please allow me to use this information for this and that activities? Yes or no? So they really moved the ownership of data from companies back to the human. And if we think about data in a company, it just keeps moving around. It's created in one place, it's stored, and then you just move around, transform, and consumed by Excel or by dashboards or whatever at the other end. And when you think about GDPR that require you to know which information is processed in which way, for which kind of need, who can access it, in what way, via what tool, or for what need, well, it's obvious that for a GDPR assessment, you need a full data lineage, because otherwise your assessment will just be like I guess I'm quite good with GDPR, but let's say that I have just no idea practically. And keeping GDPR super simple, we can see it as if you know where the data is stored in your company and what information you are storing, and then if you know who is accessing this information and why, many people thought that's GDPR, so I'm good. This translates into what database store my information. Oh, that's easy. I exactly know what database in my company store what. And I also know who can access it because I did some cleanup. So I removed some permission, I removed some grants. So I did my job. I'm GDPR compliant. Job done. Sorry, it's not as simple as that. For data lineage, you really need to follow the origin, all the transformation of your data, and where it goes, where it's consumed. And this is really what the GDPR part is about, and also why data lineage helps you. It's obvious. auditing, how can your auditing be done? Well, I doubt somebody will come and really read through your full code and find out what's going on. They will probably ask you some documents or some process or your data lineage to make the audit of your platform. Or else imagine impact analysis. If at some point you want to rename a database table, you can just go in the morning and rename it and waiting for 200 people to complain. And then you can just keep going and say, okay, why instead I don't have data lineage that allow me to make an impact analysis? So in this case, you can say, if I rename this column, this table, all these objects will start failing, so I can fix them before to rename the things. Regulations, as I said, GDPR, it's what took back data lineage on the front line, I will say. But any kind of regulations, like even in Switzerland, for example, we have some local regulation for financial institutions. There as well, data lineage is needed. Or simply, when your business keeps growing year after year after year, it will change, it will transform into a different kind of activity just because you are growing and expanding. So the life cycle of your business can be followed with change applied, looking at data lineage, saying, okay, now we are changing our business, we're transforming things. How can we implement this transformation without breaking everything, but just expanding things bit by bit? Or as simple as knowing what's going on. If you are, for example, a new employee in a company, if you walk into the data analysis team, if they give you a data lineage tool or a document, you can in just one day or even 1 hour find out what are the main flows of data, what are the main transformations, or just go back and find yourself the answer to where this thing comes from. So simply knowing what's going on, that's what data lineage helps you to answer. So that's what data lineage is about. Now, what about the graph part? Because I'm trying to tell you about data lineage made easy with graph databases. So what is a graph? First of all, starting from really the beginning. A graph is extremely simple. A graph is just two kinds of objects. You have vertices, nodes, rounds. Let's call them rounds. Vertices or nodes is the same word, so use the one that you prefer. And the second object is a line, an arrow most of the time, an edge. You take a bunch of them, you shake a little bit, the result is a graph database. Only two objects, nodes and edges, nothing else to create a graph database. Looking at one simple example of a visualization of a graph database, extremely simple. So all the vertices, all the nodes have an ID, like the number 5, because we must be able to identify in a unique way every single object. That makes sense. Every single node can have a label. In this simple example, they don't have any label, but a label can be used to classify the node, saying, for example, this node represents a customer. This one, it's a product. This one, it's a country. So the label is a special kind of property that really say, this node is this kind of object. So it allows you to make things easier, to make it simpler by qualifying what is the content of your graph. And then because it's called property graph, you must have properties. In this case, we see the properties here. Key values, name equal Vadas, age equal 27. It's really key values, key values, key values. The list of properties is totally free. One node can have no property, another node can have 10 property, and a third one can have 2,000 properties. It's all independent. Every single node has an independent list of properties. There is no obligation to have all the same properties across the same graph. It's totally free. The only rule is key property. You have one key, you have one value, so it's key value properties, all like that. The second objects composing the graph are the edges. So in this case, the edges, we see them here. They also have an ID, like the number 12. Again, it's just a technical information because we need to be able to identify each single one of them. You will practically never really use the edge ID. The edges have labels as well, like created in this case here. The label really qualify the the relationship between the two nodes, because one edge always connects two nodes, a source node, a destination node, and the label really is often an action, a verb that qualify what is the connection between these two nodes. And then again, edges can also have properties, like in this case, the weight equal 1. This one is exactly the same thing as the nodes. So it's key values, and the list, it's totally free. Edges can have no properties, can have 10 properties, can have 2,000 properties. Every single edge is independent one from each other. So this is really a graph database. It's extremely simple. Nodes, edges, and then properties all around. That's it. How can you compare a property graph with a relational database? Because many people are used to relational databases. So what is the, let's say, the parallel between relational databases and property graph? Well, it can be seen like that. Relational database, on one side, we have 3 tables, for example. The join is at the table level. So we have a primary key, foreign key. So we have foreign keys. Let's say this column is pointing to that given column in that given table. And that's it. In the property graph, we have nodes and edges. So it's a bunch of rounds, a bunch of lines connecting them. That's it. When we look at the record itself, our line of data, every single row in a table of the database, of the relational database, has exactly the same column. If your table has 5 columns, every single row will have 5 values inside. Even if they are null, still it's 5, not 6, not 4, 5. The join is not really the row saying, I have a join to that table. No, it's the table that has this information of this column is a foreign key from this one. So you can make a join through this way. While if you think of the graph, every single node has a flexible list of properties. So one node can have 4 properties, 5 or 6. They are all different. And the join between data, it's an edge that really link one node to one node. So it's like if in your database, you take the join and you take it one level down, more detailed, row by row. It's like having a join by row structure in your relational database. And like if every single row of your table can have a flexible list of columns. That's really, I will say, the main difference between a relational database and a property graph. Now, where does a property graph fit into Oracle? So Oracle developed PGX, Property Graph Analytics. It's developed by Oracle Labs, this, I will say, startup owned by Oracle with all these new fancy trendy development projects going on. And when they have a nice product that truly makes sense, they ship it back into standard Oracle development products. So PGX is really the engine, it's really the brain of property graph. The idea behind the PGX is, let's make it simple. We want property graph, and we want to focus on property graph. So storage, do we really have to bother about storage? No. Oracle has many solutions for storage. You can use an Oracle database, you can use a big data solution, you can use a NoSQL HBase, or you can use flat files. So storage, we are not going to bother more than that. We just make a connection layer, and then the storage is managed by something else. What about interfaces? Well, PGX is the brain, is the engine behind property graph. So it doesn't really give you a visualization by itself, but you can connect to it and just ask things to PGX, and PGX will answer you. So you can have on one side visualization tools, or you can have via REST web service or REST API. You can just ask whatever you want, send commands into PGX, and PGX will answer. But PGX itself is really just the engine, just the brain of property graph. It's a fully in-memory thing, so you have an extremely fast engine to answer graph questions. Some example of property graph. Data lineage, it's all this talk is about. I will show you an example later on in the talk. Another example of property graph usage, fraud detections. That's extremely simple. Imagine just like cleaning up, let's say like it's some money. You just send money around a few various accounts, like selling fake services to sell to a fake customer who is going to do the same to few other customers and then money come back to you. So you are doing a loop around a bunch of bank accounts. That's like cleaning up money. This loop, finding a loop that can have like a variable length, can be like a 1-step loop, can be like a 10 steps loop. In a property graph, in seconds, you find all these loops. While in a relational database, you will struggle because of the dynamic size of the loop. So you don't know how many steps the loops can be long. So in a relational database, you will struggle to write a query that really matches all of them easily. Property graph, one click, done. You find all the loops. There was also, like in Europe, the VAT fraud that was quite common. So selling fake product across countries, and because it was across countries, every country of destination was asking back VAT refund, but there was no product sold. So with a graph, you can easily track all these movements of fake products and see that the money come back at the same point at the origin, so you can easily find frauds. Another common usage, which you are probably not doing much these days, when you want to travel, going from one point to another point, finding the shortest path, finding the cheapest one, finding the fastest one. So a graph can easily answer all these things by following various rules. You say, if you have properties on your connection saying, this connection is a flight, will take 4 hours, cost you $500, and will, let's say, burn X amount of tons of whatever, you can say, okay, give me the cheapest one by summing together all the costs of the edges and then give me the cheapest one and things like that. So property graph is really good when it's all about patterns and connections. Now, back to the topic, finally. Why is a data lineage, or why actually is property graph or graph databases a perfect match for data lineage? What do a graph has that data lineage can really enjoy, and why data lineage fit perfectly into a graph? Let's look at some examples. It's quite natural to think at it when you see it first. Database. In your database, you can have some schemas. You have some users. These schemas can have tables. Every table can have one or more columns. You see, database schema, it has a table inside, the table has column inside. You can already make a parent-child relationship. Edge, node, edge, node, edge, node. Then if you think about like grants, which user can access what objects? All the grants in the database can also be mapped to a graph because you have one node for the user, one node for the object. You have one edge that say this user is allowed to select from this object. Think about your objects used by something else like views. In a database view, you often reference a bunch of other tables. So one view referencing table, referencing table, referencing table. Again, nodes, edges everywhere. When you run a query, the query will touch some object in the database. This thing will then generate some data. This data can also be stored to generate a new table. So you can have relationship there as well. All those things are just a perfect match for a graph. They can all be represented by nodes, edges, nodes, edges, nodes. It's a graph. Think about ETL. That's even more obvious. Just look at it. Look at the picture. It's blocks with arrows, nodes, edges. Looks familiar, right? ETL is a source, a target, some transformation in between. You can have one node being the source, edge being the transformation, one node being the target. That's your ETL. It's just a graph. Nothing more, nothing less. All of these things are graphs. Let's move on. So we did the database, we did the ETL. Let's move on to the analytical platform. In this case, if we think about Oracle Analytics, it can either be cloud, OAS that Francesco was talking about before, OBIEE, same tool in the end. How can it be seen like? Well, you generally have a physical column, which is a database column. This column is mapped to a logical column. because the power of Oracle Analytics is to have these abstraction layers on top of the physical sources. You have the logical models, and then you can expose them for making analysis. So the physical column is mapped to a logical column. The logical column is referenced by a presentation column. This presentation column is referenced by an analysis. So on your screen, you're building an analysis to find out some information. You're referencing a presentation column that go back to a logical one, that go back to a physical one. This analysis can be contained into a dashboard page. And the dashboard page obviously is part of a dashboard. And what about security? Well, you can have security by application roles having permission on top of analysis. So the application role has, for example, open and edit and delete permission on the analysis. But who is part of the application role? Well, you can have an LDAP group with a member of the application role. And who say LDAP group also say LDAP user. So an LDAP user is part of a group, which is a member of a role, which has some ACL grants to an analysis, which is into a dashboard page on the dashboard, which reference a reference column, logical column, and database column. All of this, again, is just a graph. If you look at it, it's nodes, edges, nodes, edges, nodes, edges, nodes. It's a graph. If you're thinking about the new data visualization interface of Oracle Analytics, again, Cloud OAS or OBIEE, so this data visualization interface, which is more the self-service one, you can have a database column or an Excel file column. It's used by a data flow to create a new data set in DV. So you have already a 3 nodes, 2 edges graph. This dataset column can be used by a machine learning model. So you train your machine learning on top of this dataset. So you are using the dataset column to train your machine learning model. But then you can have a new data flow that say, hey, I trained a machine learning model. Let's do some predictions. So the data flow will apply the machine learning model to predict a new dataset column, which contains the result, the output of the machine learning model, the prediction. And then you can say, now I have some predicted data. Let's do an analysis. So you can build a visualization with a table, a chart, a pie chart, bar chart, whatever. So you are using the dataset column in your visualization. And this visualization can be shared between many users. So here again, it's just a graph. You have nodes, edges everywhere. Everything is about one object related to another one with a relationship, and then so on, so on, so on. So everything so far has been a graph. And just to give you an idea of how a graph can look like for OBIEE related or Oracle Analytics related applications, if you maybe know the simple application 607, it's already a bunch of years old, but it was this virtual machine with every single possible example for OBIEE inside. This one, just OBIEE itself, so without the database or ETL, just the OBIEE part can be a graph of 45,000 nodes and 105,000 edges. And it's a small example. If you are familiar with Oracle Business Application, or OBIEE apps, OBIEE apps, it's a huge thing. It's a tool made by a bunch of pre-built analysis, pre-built dashboards, a pre-built data warehouse, pre-built ETL. If we look only at the Oracle Analytics part, only the catalog and the RPD, without the security, without the ETL, without the database, this one generates a graph of 550,000 nodes and 1,700,000 edges. It's already a nice little graph. And it's just like one single tool. It's only part of your enterprise analytical platform because it's just the BI apps part. It's not the ETL, it's not the database, it's not all of these. But you can easily see that your graph can easily get bigger and bigger when you start bringing all the data. Now, why am I saying that a graph can help you for data lineage? If we focus for a second on Oracle Analytics solution mainly, you already have a bunch of tools out of the box. You have like usage tracking, you have the repository documentation, you have the catalog reports, you have options to make analysis. They are disconnected elements, and there are missing bits there inside. That's where a graph can help you collect all the information together and have a full picture. What are these missing bits? For example, catalog shortcuts. The catalog of your Oracle Analytics system can be seen like a file system, for example, and a shortcut, it's like a symbolic link. You are just showing something in a position of the catalog which doesn't exist there. It's just pointing to something else somewhere else. And these shortcuts, when you use the out-of-the-box tools, they are invisible. They don't appear as shortcuts. But when you start migrating objects between dev and test and prod, for example, you often end up with a migration which doesn't work because there in the middle there was a shortcut and you forgot to take the source of the shortcut. You copied the shortcut, which now points to something that doesn't exist. When you use a graph, you can easily map all those shortcuts and saying, oh yeah, this thing is actually a shortcut to this one here. So if I want to deploy to prod at this object here, keep in mind I needed this part as well because shortcut going through. Another one, which is a most common error and a problem that the out-of-the-box tools doesn't cover, aliases. Oracle Analytics, it's smart enough, mainly in the RPD, when you rename something, because it's all about applying business names to things to allow users to understand what they are in front of them. So when you rename objects, the RPD will keep the old name as a reference, as an alias. Problem is that by default, it will not, let's say, change all the objects that use this reference. It will only rename it in that given place. And because it does the alias, say, well, if there are analysis or prompts or pages using this column with the old name, the alias will still match. So you have a match, you don't have an error. Problem is when you use the out-of-the-box tools, the aliases doesn't exist. The analysis does only work on the real name of things. In this case, for example, we see that this column here actually can be referenced by 3 different ways. There are 3 more names that give you the same exact thing. Here you see it on the side, it's 4 times the same information with 4 different names. The real name plus the 3 aliases. The graph allows you to easily find out all these things, to easily keep track of all the aliases, where they point and what they are. Out of the box tools, you will just say, oh, my database column is not used anywhere. Well, it's used everywhere, but it's the alias that it's used. So the out of the box tool will miss it. Well, if you do a full data lineage yourself with a property graph, the backend to store the information, you can say, oh, beware, there are aliases there inside. So I maybe want at some point to clean up the aliases, like change in the analysis the reference and then remove the aliases to keep things clean. A more simple example that you can use and you can apply to actually everything else. It's not only Oracle Analytics, but it's also valid for every other application. Security. Security by default is always about inheritance. You generally never apply security on every single user. You just create groups, which can be members of other groups, and then you apply security at this level, at the group level. You say, well, all the inheritance will just do the job for myself so I can keep security smaller and cleaner. But then you can end up like in a super simple security like this one, even if it looks rubbish on the screen. We have in blue users, in green groups, and in red application roles, and you say, yeah, you have these users, Leslie. I'm quite sure that not many grants are there, so Leslie cannot do many things. It's supposed to only be like a bunch of reading some analysis. Is it really the case? Well, during the life cycle, things happen, and surprise, Leslie is actually a bunch of things. Leslie ended up being a BI service administrator. So it's a full admin of your platform. Why? Well, because it ended up being part of a temporary group that has been created to fix a little issue while we were waiting for security to deploy a fix that we asked some new grants. So we did a temporary group in the meantime because Leslie really needed the access to something. And then we forgot, but somebody took this group because it had many people inside that we needed for something else, and it had become a BI admin group, and Leslie ended up being an admin. Nobody was aware. In the security, it's just like 5 steps away. You have 5 inheritance steps. 5 is still small. If you apply if you take a real corporate security, it can be 50 steps away. A property graph always allows you with one click to find all the grants that every single user has, resolving all the inheritance, whatever distance they are. They can be 2 steps away, 10 steps away, 200 steps away. The graph doesn't care. In less than 1 second, it tells you beware, this user actually has all these grants. Why? Well, this one comes from this path, this one comes from this one, this one comes from this one. So all these things are activities that the graph really do in clicks. Now, what can you do with this graph? Because I'm telling you, you can do your data lineage with your graph, but what can you do with a graph once you have it? It's simple in a way. You can visualize and analyze this graph. Makes sense, otherwise why to make it? How can you do it? Well, with the last release of property graph in Oracle, released in last January, you have the graph visualization. With the graph visualization, it's a lightweight web interface that you can point to a graph and start navigating around. You can write a query, and then you say from that result, you start navigating. For all the objects that you retrieve from the graph, you can see all the properties. So in this case, you can see that I take one node. For this node, for that node, I have all the properties. Then you can have some actions, like you can say, okay, this one, I don't need it. Drop. It's not a real drop, it's only hide. So it's take this node out of my screen, I don't want to see it. Or you can expand it. Say, what are the edges that go somewhere from this node? So take this node, expand it, load all the edges around. And from there, you can start navigating. You start from one point and then you start navigating around. You jump around, and at the end you end up with something like this. You can say, oh, I have this dashboard page here that reference an analysis here, which go through logical and presentation column, end up using this physical column, which is a database column. So with a bunch of clicks, I just find out exactly what is used by this analysis, and I say, okay, so my column that I see on the screen with this number that I couldn't find out where it came from, it actually comes from this thing here. So I can go and analyze more in detail. Other things you can do, cytoscapes, for example. So the property graph visualization, this one, it's a web light interface. Cytoscape is an open source tool. You install it on your desktop, on your laptop, and then Oracle gives you a connector to connect to Oracle Property Graph. And Cytoscape is really for property graph analysis. So this thing is not me painting in the evening. It's a simple application 607 property graph. I can say, oh, there is one column in my database, which is a sensible column. I need to take it out or just make sure that only few people can access it. What is the situation right now? How can I find out where it's used? The graph can answer you in seconds. This column down here is actually referenced by all those things here on the screen. So in just seconds, I went from 45,000 nodes, 105,000 edges to 85 nodes. As a human, I can process by hand a list of 85 entries. I can clean them up one by one. I can go in, edit the report, remove the column because it has nothing to do there. Done. I cannot process 45,000 objects. So the graph in seconds tell me if you want to remove this column from here, you have all these things to clean up. Seconds. 2 clicks, I have this answer. Third option, if you have your own tools, reporting tools, interfaces, you can write a custom visualization. So this one is a web page that I did by myself. It's the same exact information as before. Here you see we have a name with all the RPD objects, with all the catalog objects. It is the same name, RPD objects, catalog objects. It just built by myself into a web page by using JavaScript libraries. I can do this one because Property Graph PGX has this REST interface. Thanks to the REST interface, I can integrate it where I want. Now, how can you make analysis on a property graph? You have about 60 algorithms that exist out of the box. things like page rank, shortest path, finding connection, or finding a bunch of things. Many of them are quite exotic. It's really property graph theories. So they are extremely powerful, extremely fast, extremely quick. Sometimes a bit complicated to understand, but if you read the doc, you find out easily what they are because Oracle grouped them by need, like finding path, you have a block of algorithms. Finding page rank or categorization, you have another block of algorithms. Machine learning, you have another block of algorithms. And then how can you actually query a graph? How can you practically use a graph? That's the queries, PGQL, property graph query language. So the graph is not a database, so you cannot do SQL in your graph, but Oracle wrote a language called PGQL, property graph query language. The idea is people are used to do SQL. So what about extending SQL by adding inside the graph bit? If we add a graph into SQL, we allow a majority of people that are used to make queries to actually do property graph queries. And so they started writing this language and they went on with this approach. It's really a way to extend it. It's not a standard. It's an open source thing that Oracle did. Nobody else in Oracle is using it so far, but they really took the approach of let's extend SQL and make it simple. Now it's worth noting that because it's not a standard and every single property graph database has its own language, which are not standard neither, they are finally all together, Neo4j, Oracle, SAP, and a bunch of other companies. They all got together, they developed a real SQL extension to the standard, the real standard SQL, and it's undergoing voting at the International Standard Organization right now. Hopefully it will be an official standard in the next 1-2 years maybe, so that all the property graph databases around can speak the same language. So what does PGQL look like? It's extremely simple. Look at this one. Select from, where, group by. That's SQL. I need to explain you what they are. The only thing you probably don't know, it's match. Here inside you have the match thing, the match clause, but just take a step back and look at it, how it look like. Round brackets, rounds. Oh, this one is maybe a node. And then you have an arrow. Here you see that you have an arrow that starts somewhere, it has something in between and then points somewhere. An arrow being an edge. So in this case, we are saying, please select a node with a label person and reference it as the variable P. P has a property name equal Nikita. In this graph, it's this one here, label person, name Nikita. From there, please actually find a edge of a label owner of. Oh, look, there is one here. So we are here, we're going down here, go into an account. Makes sense, it's an account, and then follow a transaction edge. It doesn't have an arrow, can be this one pointing in, can be this one going out, and then go to the account on the other side, and then from the account, it must be owned by personal company. So it's saying, take this one, follow this one, follow this one, follow this one till here, take this one, follow this one, follow these two, till this one, follow this one till here. So that's what the query is. It's extremely visual. You don't need to understand the full detail of the query, but even without knowing PGQL, if you look at how it looks like, you can understand visually what it does because it does these round brackets, arrows, round brackets, so it's visually easy. Last bit, you can easily access a property graph in Oracle just because of this REST interface. So the graph speak Java, speak Python, via JPipe, speak any other language. Thanks to the REST API, every single language that is able to act as a REST client can interact with the property graph in Oracle. You can also have a standalone command line interface. You can have a client server setup. You can use your Oracle database as storage and therefore doing queries on your database directly without the property. You can use notebooks, Zeppelin or Jupyter. You can use a bunch of ways to interact with the property graph. Java doc, you have the full Java doc. So if you want to customize things, you find everything inside. It's really a complete doc. It's really nicely done. The REST interface, you don't need to guess what the RESTful service is. You have a Swagger file, open the file with Swagger, you find out all the endpoints, you find all the parameters, so you find all the details. So what is the link between property graph and the graph database? Well, the graph database can be used as storage backend for the property graph, it can be in the cloud, you can use the autonomous graph, you can use the database as a service graph, or you can use the soon to come Oracle Graph Cloud. It's still in development. It's going to be live at some point soon. It will be a notebook-based tool with also some wizards to easily automatically create graphs on top of databases or files. You can have it on premises. If you have an Oracle database in your company, as long as it's a 12 CR2 or newer, you're good to go. No license anymore since December last year. As long as it's a supported database, you have property graph for free now. If you have the big data appliance, you have property graph there as well. If you want the free option, you can go with the database 18c-XC, which is free, limited resources, but it's more than enough. Like it's, I guess, 2 CPU, 2 gigs of memory, and 12 gigabytes of storage, something like that. Or you can go with the always free tier on the cloud. You can create an always free account in the cloud, create an autonomous database. You have 20 gigabytes of storage. It's more than enough to store a graph there inside. So this is some screenshot of the cloud service. It can still change. So don't take the screenshot for a fact. They can still change around. Now, what's the point of all this? The point is all of you need to have data lineage. In a way or another, you need it. If you don't have it, I'm not sure how long you can keep going without, because you will start soon losing a lot of time trying to remember, this column actually comes from there, comes from there, comes from there, but there was a dependency there. Somebody sent me an email asking for this bit, but I don't remember who. Data lineage, you need it. Every single tool you use in your company, a database, ETL, analytical tool, whatever tool, must have some metadata, must have some logs. You can use those information to actually build your data lineage. And because data lineage is all about something starting somewhere, going somewhere, going somewhere, going somewhere, going somewhere, that's a graph. So what else than storing a data lineage into a graph database? It's just the best match. It has the right structure. So use a graph database to store your data lineage. Then you can have many ways to analyze these things. You can access them by multiple ways. You can even make standard queries on top of it. So don't take as an excuse that you cannot query it after you build it. If you store your data lineage in a graph databases, the query part, the analysis part is the easiest possible ever. It's not the biggest problem. The challenge is really about getting all this information into it. In data lineage, the challenge itself is collecting logs, collecting metadata. For some tools, it's easier. For other tools, it's more complicated. So that's really where the challenge is. There are companies out there that sell you magical tools that make data lineage for everything. It doesn't exist. Even Oracle struggled to really have a tool making data lineage by itself automatically. It's mainly by application data lineage. Like inside the ETL, you have the ETL metadata that you can analyze inside the ETL, but you don't have the pieces before and the pieces after. So the Oracle tool that they had, it was super expensive, and I actually never really saw it used for real. And because of this complexity in collecting the information, scripts are really there to help you. Do not try and hope to do data lineage by hand. You cannot collect all the data lineage information by hand. Script it. Once it's scripted, it will take you not much longer than doing it by hand first. And once it's scripted, you can execute it again and again and again, as many times as you want. Finally, graphs are just fun. So even if it's not for data lineage, look at graph databases just because it's fun. It's a different way to represent information. You represent data in a different way. It's the same information, if you want, with a different approach to it. It's like asking different questions, having different answers out of the same information. It's not going to replace your relational database. is going to extend it. You can complement it. You can have your relational database, your property graph, and just ping pong each other and just use what one can do better than the other one and so on. So that's really the best way to get the most out of it. Finally, just because I said about scripting, all this previous example, all these previous things about Oracle Analytics, they was saying the size of the graph, all these things. Well, guess what? That's why I did it. I just wanted to find out one day if it was possible. So I started scripting everything. And now I have a little script that I run against an Oracle Analytics platform, and I collect everything. I have the full data lineage of an Oracle Analytics platform, cloud, on-premises, OBIEE, OAS, whatever. One click, I have a nice graph out. As simple as that. Script it, script it, script it again. And almost on time, we're at the question time.
Yeah, Gianni, can you go back one slide, please? Because there was one question to exactly that slide that you were standing on.
One slide will mean which one?
Yeah, this one, stop. So, because Julia asks here, how do you extract data from OAS, OBIEE to the graph database? What tools do you use?
There are many ways to do it. I will say for OBIEE, you can use either web services to query data live out of the system. But web services means you need to have a high privileged user, so a super admin, and still you are missing the personal folders of people. Now with OAS, OAC, or even OBIEE, if you generate the bar file, or you take a snapshot of your Oracle Analytics Cloud, you can extract everything from the bar file, from the snapshot. That one will contain everything, so you can just start processing everything. There is not a tool on the market that do it, I will say. That's really handmade code. I just wrote it because you have pieces of tools. Like as I said, out of the box, you have elements. You have the RPD documentation. It misses aliases, it misses all these bits, but it gives you a part of the data lineage of the RPD. You can have the catalog reports. It will miss the shortcuts, it will miss other pieces, it will miss the user folders, except if you do it offline. But it gives you only pieces of information, and you have to connect it to RPD documentation by hand. You can have the user tracking that again will extend the information, but you have to connect it by hand. So this tool here, it's really a handmade, made tool that I did myself to automate the full extraction. It's using the various APIs when they exist on top of the various components of Oracle Analytics, or just by knowing how Oracle Analytics work and store things, extracting all the information by parsing files and various things. So that's why I say this is clearly the challenging part. The extraction of metadata is the challenging one. Analysis is the simple one.
Yeah.
So if you actually want to have more hints about this one, I wrote a bit on the blog post about where you can get the things from the web services. And then in case, just get in touch and we can go into more details of how things are done and not.
Yeah, so for the data sourcing and storage, we have a question, data source for graph database only from database. I asked the clarification question, so storage or the source of the database, and it's actually both for storage and for the graph source. So where do you get the data from for the graph, and where do you store it, basically?
So the Oracle property graph can use the database as storage, and it will be only an Oracle database. You cannot use another kind of database for storage because it's a predefined, pre-structured set of tables. So when you want to store a graph in the database, you call a package that exists in your database. It will create 5 tables with a set of columns. You cannot touch them, you cannot rename them if they are pre-indexed, pre-whatever, pre-partitioned. So that's the storage in the graph, in the database, in the relational database of the graph. To load from a database into the graph, I will say that in that one, you can load from various kind of databases because there are many ways to load. You can load from what is called the 2 tables load. So you just have to, let's say, if you create a view in your database that represents all the nodes and one with all the edges, you can say, hey, Oracle property graph, look at these two objects and load from them. Property graph is written in Java, so it's a JDBC connection. If you connect by JDBC to a database, you can load from it.
So basically any data source that can be attacked via JDBC can be used as a source for a property graph.
That one, or there are various, let's say, gateway. There are various ways to move some data from a database to the property graph. Just even doing a simple transformation between or whatever. There are many ways to do it. Oracle obviously covered the Oracle database to Oracle property graph way. They never really wrote anything about other databases, but it's Java, so it's a JDBC connection. Why not? It's standard queries in the end, so must work.
Then next one, do you prefer Oracle Graph or Neo4j and why?
So I clearly prefer Oracle Graph just because it fits more into my fully Oracle environment with all my Oracle things around. I would say that the thing is that Neo4j is totally is a full product. You have the storage, you have the interface, you have the visualization, you have the query part, you have everything. And Neo4j, it's only that. The power for me with Oracle Property Graph, it is that it's a simple other way to see the same information on top of existing tools. Like if you have an Oracle database, you can easily load data into your property graph and then back into your database without needing this extra tool. Just because the property graph is an extension of the database, and then it's a add-on, plugin, not sure how to name it, of the database itself. While Neo4j will be a fully standalone platform, a fully independent tool, which come also with the licensing, administration needs, hardware needs, while the property graph can really be embedded into the database if we want. You can even just forget that you have a database and say, oh, I run the property graph on my desktop as a client, and I load the things in a graph in my desktop to do a graph analysis and then push back some output in the database itself. Or also you can translate PGQL property graph queries into SQL. For example, when you have a graph that changes super fast, the PGX engine works like in a snapshot mode. It's not a real-time changing graph engine. It's more, give me the graph, I do analysis on it, then I can update the graph, redo the analysis. So it works in a snapshot way. But when your graph changes really quickly, say, okay, that's nice to have this snapshot mode, but I actually need to make my queries on the real graph. Well, in this case, by being able to translate PGQL into SQL, you don't have to write SQL yourself. Just take the PGQL query, and then you can translate it into SQL, and that's why it can be really powerful. And like the Oracle way, it's more like this multi-purpose database. The database become many things. It can do a database, relational database, can do property graphs, can do web services, can do JSON, can do XML. So that's why I prefer the Oracle one. And also the algorithms part with the machine learning embedded, I like it because Oracle gives you the full source code of algorithms. So you can actually have fun reading them, if that's your kind of fun. Okay, that sounds nerdish, not detailed. Or you can actually write your own. You take the source code of a graph algorithm and you just extend it with your own bits. There is a customer in Bulgaria that did that, and that's not something you can easily do with Neo4j, at least as far as I know. And it will really be a different product, different tool. While Oracle Graph, it's Oracle in the end.
Okay, then we got another one here. Is it possible to use OWM to extract metadata into the graph database? And then I mean common warehouse meta model.
I would say there is not an automated out-of-the-box connector. The property graph bit really joined the database fully not so long ago. So it's really an extension and add-on, and it's still not, let's say, implemented or connected natively to any other tool. It's there to be used as an extension of the database, but it doesn't have connectors to anything else. So I don't have a hands-on experience on the OVM to extract metadata, so I'm not sure what kind of metadata it gives you. But the thing is, you will need a manual bit to translate one thing into the other, because you either have to load it in the database and then format it for the property graph storage in the database and so on. So you need a manual bit in between. I will say the connection bit between tools and the graph, it's still you. You're still the piece connecting the two elements. That's where I say that you need to script things, and you will have to spend some time doing it because it's not available out of the box, but it can be done. By script, you can do everything. So it takes some time, but once it's done, you can really enjoy the benefits.
All right, so I'm just going through the questions. So we had one from Mark. Can it read the ODI repository and get detailed transformations?
Yes, you can. ODI store all these things in the database, so you can extract everything from the database. I don't have the queries handy, but I know that, for example, a few people did it. They had presentation about that. They had scripts around. So you will have to search to find the references, but it's absolutely doable. ODI store everything in the database. That's why it's easy to extract all the metadata.
Okay, then what else do we have? Oh yeah, I think we had another one about the APIs to extract from the graph database, but more specifically related to OBIEE. Sorry, not from the graph database, but for the graph database. So what did you use to extract the metadata of OBIEE/OAS/OAC?
So what do you need for that?
What did you use?
What did I just use
the APIs basically.
The public web services. So if you look at the OBIEE web services, you find them. Then for the data visualization part, you have another set of APIs which are documented. There is Oracle Analytics team did a public YouTube video documenting the API for data visualization part. You could, in theory, use read-only, please, read-only the database. Yes, you can get the information out of the database because it's stored there. OAC because it's fully sealed. You can only get it either via the API. So it's a REST API that you call that can give you all the data sets, all the data flows, all the machine learning models, and so on. Or you can use the snapshot. You create a snapshot, you download it, can be scripted because it's REST calls, and then good to go.
Great.
I think not everything is documented. Most of the APIs are there, they are used, not fully documented. That's why I say it's the challenging part. But Oracle clearly said they are doing some work on the documentation of APIs. They are going to publish a bunch of new APIs for OAC, OAS in the next months, hopefully, which are supposed to make all of these public and not just looking what is hidden under behind the screen.
All right, I think these are all the questions for the moment. If anybody has anything more, then please feel free to ask now. We still have 1 minute until the next session, I just saw. No, there's silence in the chat for the moment, so I think we're good.
They are all downloading a rough database, that's why.